This. All right, so answers for the pvnRT. All right, now a couple things you want to note about this. You watched the video, but the pressure for this guy has to be in atmospheres. This guy has to be in liters. This guy has to be in Kelvin. The N is the number of moles. The R is 0.0821, and that's calibrated with these units in mind. All right, so now whenever I run one of these, it's purely mathematical at this point. So we got term number of moles. So PV equals nRT, solving for number of moles. So it's going to be PV over RT equals N. And I like to rearrange it first. Plug your values in. Number of moles, what I'm looking for. So 1.5 liters. All right, so it's going to be 1.5. STP stands for standard temperature and pressure, which is going to be 0 degrees Celsius, which is 273. I'll go ahead and plug that in for my temperature, which goes on the bottom, 273. R is 0.0821. The pressure is also standard at 1 atm. Just an FYI, 760 millimeters of Hg equals 1 atm. Another name for mmg is torr. Good? Plugging this in here at 1. Take your calculators, punch it out. 1 times 1.5 divided by 0.0821 divided by 273. Checking to make sure I got the same as me. I got 0.066. 0.0669, and that would be moles. Good? Going on to the next one. What is the temperature of a sample of air at 1.5 atmospheres, moles? Okay, so again, purely just mathematical. PV equals nRT. Looking for temperature. So PV over nR equals T. Start plugging the values in. Pressure is 1.5. The volume is 1.1. N is going to be 0.05, and R is 0.0821. Take a moment, calculate it out. This answer will be in Kelvin. Someone gets the answer, let me know. What do you got, Sam?
401.95.
Okay. We'll stick with 3 sig figs. All right. If a balloon has a temperature of 298, a volume of 1.98. Again, important piece of information. 1 mole of gas. Okay, now, looking for what is the pressure? PV equals nRT. So P equals nRT over V. So N is 1 mole, 0.0821. Temperature is equal to 298. And all that over the volume, which is 1.98. Yes?
When we take a test on this, do we have to actually rewrite the formula like that?
I would like to see some work, however you do it.
Okay.
It doesn't make a difference. And the math in this, Brandon, what's the answer to this one?
12.3689.
There we go. A balloon filled with helium has a volume of 250 milliliters. I'm not going to 0.250 liters. STP stands for 273 Kelvin and 1 atm. All right, so what is the mass of the helium? So at this point, in our formula of pvnRT, P V equals nRT. You don't have mass here, but N moles can get converted to mass with the molar mass of helium. So at this point, we'll solve for N. N equals PV over RT, and therefore, let's put it over here. The pressure is 1 times the volume, which is 0.250, divided by R, which is 0.0821, times temperature, 273, will give you N. Okay. What is the math on this? Raise your hand if maybe you want to volunteer an answer. Not everybody at once. Are we calculating? I got 0.011. All right, that's moles. So now, keep in mind the molar mass of this guy, 4 grams per 1 mole. I have 0.011. So 0.011 moles, dot line, get rid of moles and go to grams. 1 mole is 4 grams, equals 0.044. I don't know if you can see that or not. 0.0044 grams. All right, number 5, I have the moles provided. What's the pressure? So it's going to be giving me a temperature of 298 Kelvin, pressure in atmosphere, so P equals nRT over V. That's as far as I'll take that one. You can take your time and plug that one in. Number 6, what is the pressure in millimeters of Hg? All right, so they want a different unit here. 1 gallon rigid container with a temperature of 212, 4 grams of helium. So, looking for pressure. So P equals nRT over the volume. And let's start plugging in what we know. We have the volume is 3.78 liters. It's a rigid 1 gallon. That's equivalent to 1 gallon. R is 0.0821. Temperature is, now it says 212 Fahrenheit, which is the boiling point of water, which is 100 degrees Celsius, which is 373 Kelvin. And number of moles. Just in case you didn't catch it from the last problem, helium is 4 grams per 1 mole, so we have 1 mole. At that point, you can do the math and calculate. The answer will be in atmospheres, so I will delete that square. We'll do one last calculation. Check my math. Is it 8.1 atmospheres? Again, that answer is fine, but they want it in millimeters of mercury. So 8.1, get rid of atmospheres and go to millimeters of Hg, 1 to 760. And 8.1 times 760 equals 6,157 torr. Same thing as a millimeter of mercury. Number 7, a clown puts 15 grams of nitrogen in a balloon. Has to be, what's the volume? All right, so 15 grams to moles. 1 mole of nitrogen gas is N2. Keep that in mind, is 28 grams. 15 divided by 28 equals 0.53 moles. Now I'll just make a little side comment here that at STP, there's 1 mole of any gas equals 22.4 liters. So you could use this conversion if you're at STP as opposed to doing pvnRT. So 0.53 moles, because I'm at this, I get rid of moles and go right to liters. 1 mole is 22.4 liters, and 0.53 times 22.4 is 12 liters. I could use pvnRT, PV equals nRT, plug in all my variables, solving for volume, and I'll get the same answer. Number 8, it says an empty bottle has a volume of 591 liters, immediately converting that to 0.591 liters. Assume the bottle is filled with only nitrogen. What is the mass of air in the bottle at STP? All right. Again, I can use this conversion. I'm going to use pvnRT instead, just for this one. PV equals nRT. And they want to know the number of moles in that bottle, and then I'll convert that moles to grams, because it is nitrogen gas. So it would be PV over RT equals N. The pressure is 1. The volume is 0.591. R is 0.0821. And T is 273. I got a whopping 0.026 moles of nitrogen gas. Check my math. And now we'll take this, get rid of the moles, and go to grams. 1 mole is 28 grams. Equals 0.73 grams of N2 gas. Questions?